Hey guys, welcome to our channel, and today we're going to learn about exponents and square roots. Don't forget to like and subscribe. Cheers!
What are exponents? Exponents, also known as powers, are values that shows how many times to multiply a base number by itself. For example, 4 cubed is telling you to multiply 4 by itself 3 times. 4 cubed equals 4 times 4 times 4 equals 64. What are the different rules of exponents? There are 7 exponent rules or laws of exponents that your students need to learn. Each rule shows how to solve different types of math equations and how to add, subtract, multiply, and divide exponents. Number 1. Product of power rule. When multiplying two bases of the same value, keep the bases the same and add the exponents together to get the solution. Number 2. Quotients of power rule. Multiplication and division are opposites of each other. Much the same, the quotient rule acts as the opposite of the product rule. When dividing two bases of the same value, keep the base the same then subtract the exponent values. Number 3. Power of a power rule. This rule shows how to solve equation where a power is being raised by another power. Number 4. Product of a power rule. When any base is being multiplied by an exponent, distribute the exponent to each part of the base.
We have the power of a quotient rule. A quotient simply means that you're dividing two quantities. In this rule, you're raising a quotient by a power. Like the power of a product rule, the exponent needs to be distributed to all values within the brackets it's attached to. Next, we have the zero power rule. Any base raised to the power of 0 is equal to 1. The easiest way to explain this rule is by using the quotient of powers rule. Following the quotient of powers rule, subtract the exponents from each other, which cancels them out, only leaving the base. Any number divided by itself is 1. No matter how long the equation, anything raised to the power of 0 becomes 1. Typically, the outside exponent would have to be multiplied throughout each number and variable in the brackets. However, since this equation is being raised to the power of 0, these steps can be skipped and the answer simply becomes 1. Next and the last, we have negative exponent rule. When there is a number being raised by a negative exponent, flip it into a reciprocal to turn the exponent into a positive. Don't use the negative exponent to turn the base into negative.
Alright, we're already done here.
Hold on! We still haven't discussed the opposite of exponents. The inverse operation of exponents are called roots, or square roots. A square root of a number is a value which in multiplication by itself gives the original number. The square root is an inverse method of squaring a number. The square root of a number is a value that can be multiplied by itself to give the original number.
The symbol used for square root is the radical.
While radical expression is an expression containing a square root, and radicand is a number or expression inside the radical symbol.
Now that you have an idea about square root, here are some examples. In the square root, there are two ways to differentiate some square roots from others. Those two are rational square roots and irrational square roots. Let's start with the rational square roots first. A rational square root is basically just the square root itself. What do I mean by that? Well, take the square root of 9 for example. What number do you need for it to multiply with itself that it equals to 9? 3. Therefore, the square root of 9 is 3. This is an example of a rational square root. Now, what's an irrational square root? These are numbers that you can't square root. Examples of this are the square roots of 2, 5, 11, and 19. However, there is a way to simplify an irrational square root. Take for example the square root of 72. Since there's no number that can be multiplied by itself to equal to 72, let's use a different option. Let's take the factors of this irrational number. Those would be 36 and 2. Now it would look something like this. Now, it's time to separate those two in order to complete it. The square root of 36 times 2 equals to the square root of 36 times the square root of 2. Then you simplify the equation to get 6 and the square root of 2.
So you want to learn about complex numbers. Don't worry, unlike your life and current aspirations, they're not that complex. And pathetic. If you're wondering, what's the difference between other numbers? Well, for real numbers, you have this. For pure imaginary numbers, you have that. And then this is a complex number. A complex number consists of a real part and an imaginary part. Here are the following properties of the imaginary number I, or letter. Number I. Keep that in mind because we're going to be using that to solve. So what if we want to write this number in terms of I? Well, we're going to factor out -1 in the radicand, use the product rule for radicals, and bada bing bada boom, you have your answer.
Time for a summary. Laws of exponents. There are 7 rules or laws of exponent. 1. Product of power rule. 2. Quotient of power rule. 3. Power of a power rule. 4. Power of a product rule. 5. Power of a quotient rule. 6. Zero power rule. 7. Negative exponent rule.
Square root is a factor of a number that when multiplied by itself, it gives the result after the radical. The radical is used to denote a square root. This is what it looks like.
And that concludes the end of our video. You learned the basics of 7 laws of exponents, square roots, radical numbers, rational and irrational square roots and their differences, and finally, complex numbers, my favorite, because I taught you that. Don't forget to like and subscribe and share it with your friends. The channel has been working really hard in videos, and we just lost monetization due to something called copyright claim. See you next time!